Hello, welcome to our expert talk. So even today we have another exciting topic for discussion today, and that's artificial intelligence. What is behind it? How can artificial intelligence be used and leveraged in the area of regulatory anti-financial crime compliance? Why are we only now talking about such a deployment or the usage of of AI in AFC compliance? And what kind of use cases seems to make sense, and how to use it so that the regulator would agree on that one. And finally, how do we get started? So quite interesting topics. And it's not only about the topics. I have also very interesting guests today to have the discussion with, including two colleagues from Alexander Thamm, GmbH. And Alexander Thamm, for those who might not know them, they are one of Europe's leading AI service company and involved in plenty of AI projects throughout Europe. So I'm very pleased to welcome Jörg Bienert, partner from Alexander Thamm and president also of the German Artificial Intelligence Association. I also welcome Christian Oedingen, principal data scientist at Alexander Thamm. Heiko Möller, who is a lead RegTech consultant with MSG Rethink Compliance, so a colleague of mine. And last but not least, me and myself, Dirk Findeisen, managing partner at the MSG Rethink Compliance. So, Jörg, Christian, Heiko, maybe you will also give us one or two sentences on your experience and especially about your experience in AI.
Thank you very much, Dirk, and thanks for having us. As I said, my name is Jörg Bienert. I'm on one hand partner at Alexander Thamm GmbH. Alexander Thamm is one of the leading service companies focusing on data and AI in Germany with more than 300 employees. And our core asset is the experience of more than 1,000 projects that we did in the data and AI space, mainly for large German customers, DAX 30 companies like BMW, Daimler, Porsche, Deutsche Bahn, Munich Re, Allianz Insurances, and many other large corporations. We help them to get on speed on AI. So we do strategic consulting in the data and AI space, but we also implement sophisticated BI and AI applications in all areas of the supply chain. And on the other hand, as Dirk mentioned, I'm president of the German AI Association, which now gets 4 years. So we founded this 2018 in order to support the German economy to get up to speed on AI. And right now we're having more than 400 member companies. MSG Rethink Compliance is one of them. And we are deeply involved in discussions around AI and data regulations on a German and EU level. And we are also deeply involved in all kinds of discussions about AI strategy on a national level, on a level of the states, and helping people to design programs, projects for fostering AI and the usage of AI in the German economy. And with this, I would like to hand over to Christian.
Thanks, Jack. Hello, everyone. My name is Christian Oedingen. I'm a principal data scientist at Alexander Thamm. I've been with the company for almost a year. My background is with mathematics, and I've been involved in investigation and prevention of white-collar crime for more than 10 years, back in my time at PwC before I joined Alexander Thamm.
Thank you, Christian. Heiko, some words on you.
Exactly. So I work for MSG Rethink Compliance. I'm a RegTech consultant and mainly responsible for development of data products in general, and also developing and implementing AI machine learning use cases, especially focusing on compliance relevant topics. Yeah, and originally I also have a scientific background. Used to be a physicist, where I also worked with a lot with data-driven topics. So yeah, exactly.
Okay, thank you. Yeah, so it's a very good crowd to discuss on AI, especially before we start and talking about use cases and so on. As I heard a lot of topics about artificial intelligence, obviously also depending on our provision. So consultants always talk about AI whenever they like it, even if it's not really AI we are talking about. So it's business intelligence. There is a sort of advanced analytics, and nowadays everything is crunched together under the artificial intelligence topic. So maybe we should spend at least 5 minutes to discuss what exactly is artificial intelligence, what is our understanding about artificial intelligence, and what is the development. Because when I first built my first neural network, that was 1995, around that one, 1995, 1996. And the origins of artificial intelligence are back to the 1960s, 1970s, with a sort of a breakthrough in the 1980s. So maybe we should have a discussion why it took so long in general to utilize on artificial intelligence in general, and why it took so long that we even now have to discuss artificial intelligence and the usage within regulatory compliance. Maybe Christian, what's your opinion about that?
Yeah, thanks, Dirk. Maybe I can put some context to what you just said. Maybe we can also switch to slide one on this. So you also mentioned that we saw the first significant breakthroughs in the 1970s.
Yeah, I guess we're facing some issues with your microphone, Christian. Okay, good. So let's see whether Christian can figure out the microphone problem. But let's have a discussion on the timeline for artificial intelligence. So Christian, you're coming back as soon as you're solve your microphone. Yes, we can hear you.
All right, then let's try it like this. I just switched to another device.
Yeah, perfect.
So as you mentioned, the first breakthroughs were visible in the 1970s, 80s, as you said, but these are, let's say, with a quite limited scope, I would say. But the reason for that was basically the emerging of software in the 70s and eventually also internet in the 90s, which led to a massive increase of available data in the first place. So we have to realize that there is no AI without data, which is basically the fuel of every artificial intelligence application. And the second thing that also became much better throughout those times was basically the increase of computational power available based on improvements made on specific hardware components. So that was why around the 2000s, artificial intelligence became more of a deal, but was for the most part reserved rather for the tech companies in Silicon Valley, let's say. Whereas today, speak more of artificial intelligence 0.2, where also industries beyond the tech industries themselves make more use of those approaches.
Yeah, as you mentioned, computing power. I guess when we had the first supercomputer in 1960s, that costs about 140 billion US dollar. We had a computational power of 1 gigaflop. So even if you look on those devices here, like the smartphones, so an iPhone 7, which is I guess also an somehow an ancient device, had 11 gigaflops computing power. So that's, I guess, something that we have to have in mind, how fast the development of the hardware and the computational power went. But even that, if we talk about that, even from 2000s to today, there was an increase, obviously, but was it that much that we have to wait for usage of AI today still? So is there still a problem in computational power and data availability that, let's say, is hindering us to leverage AI?
I would say that both data availability and computational power have been increasing exponentially over the past few years, so making more and more progress. But the problem then is with more data, you also need more computational power. So it's always important to also have some kind of focus as to what data you would like to make.
So my vision, to be honest, and that's obviously you can think about whatever you want, but my vision is that a chief compliance officer, for example, or a group compliance officer, starting his day with a conversation to the machine about the situation of the risk landscape, what happened, how many risks were onboarded last day, whatever. So this kind of an or conversational artificial intelligence, will that lead us to specific large models, Jörg? And is there something in broker so that this vision can become true?
Yes, and there have been some major breakthroughs recently. So about 1.5 years ago, OpenAI, this company mainly financed by Elon Musk, released GPT-3, which was some kind of a Sputnik event, which caused a little bit of a revolution in the AI area, because they took an extremely large amount of data, of text data, a large crawl of the whole internet, together with Wikipedia and other text sources, and built an extremely large model with more than 175 billion parameters. And they took the number 5, the fifth most powerful supercomputer in the world, provided by NVIDIA, the Selene. And it took this computer about 2 or 3 weeks to calculate this model, which was an equivalent of about $5 to $20 million of compute power and resource needs. But they achieved tremendous results. So this model GPT-3 was groundbreaking in the area of natural language processing, and is the basis for more than 300 applications right now in the area of translation, in the area of text understanding, document processing, and Microsoft has used this model right now to implement, for example, an application that is able to generate programming code from natural language entries. And some people already say that this is the first step towards a general artificial intelligence, where AI systems are really able to understand a larger context, and to become intelligent on a level like humans are. I think there is still a way to go towards artificial general intelligence, but this is clearly a major step towards that direction. And therefore, these large AI models offer totally new applications in the area of natural language processing, but also in other areas, like, for example, Google DeepMind recently released AlphaFold and AlphaFold 2, a system that is able to calculate the foldings of proteins of the human body, and also provides major breakthroughs in the area of bioscience.
So the problem I see here, and that's a little bit also when you made your enumeration, you talked about Elon Musk, Microsoft, Google, however. So just thinking about what's the European Union doing, what can we expect in Germany? But I saw at least, and I guess you are involved in that as well, that we have some public fundings already given over the last weeks, also for some developments here in the European Union, so that we are not depending only on our colleagues in the US, or if it comes through on the colleagues that are working on the same stuff in China. Can we expect something in Europe?
Yes, and you're covering a very interesting and important point, that these large models are provided by, are developed by large IT companies, internet companies like Google, Microsoft, OpenAI, and others, with deep pockets. They are able to spend that large amount of money. And they provide these models not as open source, but through APIs. So if you want to use GPT-3, you can log into the Azure cloud and pay for the service. And on the other hand, have to provide the data, your data, to through this API into the Azure cloud. And this might cause some additional dependencies. And if we, the threat here is that we might come into a situation where we have monopols or oligopols on the usage and provision of AI, like we have in Google with search engines. And in order to avoid this situation, and to stay digital sovereign in this area, we are doing, for example, the project OpenGPTX, which is funded by the German government with 15 million euro, which has the goal to implement and train such a large model in Germany, in Jülich, on the supercomputer of Jülich. And with the German AI Association, we have started an initiative called LEAM, Large European AI Model, with the goal to establish continuously working AI supercomputing center with a very powerful HPC computer in Germany.
Thanks. You mentioned another important topic that we need to take care later if we talk about the use cases. And Christian, Heiko, make sure that we bring this on the table, because you mentioned you have to bring your data to those models, which is obviously always frightening a bank to do and to share data through or for the usage of AI models that are lying somewhere else, but not on-prem in their own environment. So we might need to discuss not only the data and the availability of data, but also the way we are using data in AI, and whether or not we can do it GDPR compliant and so on. So that's sort of a very important discussion, especially in anti-financial crime compliance. But maybe, so we discussed artificial intelligence, but we did not discuss really what is artificial intelligence at all. So is, for example, normal statistics part of artificial intelligence? How is there a sort of a trade-off between data scientists on the one side and AI models and AI model development on the other side? Let's have a short discussion on what AI really is. And I guess we have another slide for that one that is showcasing about what we are talking here. Anyone who feels comfortable to explain it, especially the difference between supervised and unsupervised learning, because I think that's important later to understand the use cases.
Thanks, Dirk. So yeah, I'll just take the opportunity to put some important key terms into context. So whenever we talk about artificial intelligence, today we mostly refer to the part that is actually related to machine learning. But there is also other parts to AI which are reflected here by this gray area, let's say, that can, for example, be based on experiential knowledge, classic indicator-based systems, but also the classical statistical approaches that we just mentioned. However, when today we speak of AI, for the most part, people refer to that light orange area that is based on machine learning techniques. And within the machine learning techniques, we basically distinguish between the most two important approaches, the so-called supervised and unsupervised learning. If I have to put it in a few sentences only, the most important, or what the two have in common, is that they use historic data, try to learn from it, and then apply whatever was learned to previously unknown data. The main difference between the two is that for supervised learning, your historic data needs to be labeled. So, for example, let's think of a set of transactions, for example. Some of them might be fraudulent. So for supervised learning, you would have to have information which of the historic transaction was actually fraud and which were not. And then supervised learning algorithms can detect the underlying patterns and apply what they learned to new transactions and make a classification whether or not a transaction is fraudulent or not. Compared to that, unsupervised learning does not rely on such labeled historic data. They just look at the individual properties of the transactions, for example, and try to learn something about the inherent structure of those transactions. They try to find out which transactions are quite similar to each other, which are quite different from each other, and are there some kind of outliers that do not fit into the overall patterns and therefore are somewhat, let's say, peculiar and should probably be taken into closer consideration.
Okay. I guess there's some one topic at least missing here that is always something that needs to be, let's say, in discussion if it's about the usage of AI in anti-financial crime compliance, and that's the explainability. So I know, Christian, you are a former auditor, and you know quite well that if a machine makes a decision, you better can explain to a third person that is, let's say, auditing the compliance of the system, for example, that this decision is somehow understandable, which might be an issue with AI. Can you maybe provide us one or two sentences on the explainability issue with AI? Why it's called black box?
Yeah, definitely. We can also switch to slide 3 while doing that. So what you just mentioned is, I think, also one of the key aspects as to why AI and compliance haven't met as much yet as other branches probably haven't been doing up to this point. It's not only about traceability, which is probably a generic requirement across all industries, but especially in compliance, we're also facing questions like legal admissibility, for example, if it comes to the utmost extent. So therefore, explainability of AI models becomes more and more important, because we have to admit that some of the best performing models are somewhat complex and not easily explained, especially in retrospect. So in recent years, a dedicated research area called Explainable AI has evolved to tackle this specific topic. And so there are two basic ideas that you can follow in that regard. So first of all is just to use simpler models in the first place. Just from experience, I can also tell that depending on the application, sometimes you also get stunning results just by using simpler models like regression approaches or decision trees, for example. They are more interpretable by design already. But if there is a need for a more complex model, which is not so easily explainable straightforward, and there are also other techniques to, at least in retrospect, explain as to why an AI model came to a certain decision. So, and the picture that you see here on the right at least illustrates the general idea of explainable AI, even though this picture is not directly related to the compliance area.
Yeah, that's always a problem, and that's why I think that's also an issue why the adoption ratio for AI within regulatory compliance is quite low. But yeah, just go ahead. Sorry.
So just a few sentences. So what is the general idea? So what you see here is a picture of a ladybug. And down below, you can see certain responses that the AI system gave as to what is visible on that picture. We can see that the ladybug is actually on top of the list. But the question is, how did the model came to that conclusion? And here in computer vision, we can ask, for example, please highlight the area of the picture that led to your conclusion most prominently. And this is what you see on the right. And you see that actually the right area of the picture is highlighted. And beyond that, also the model gives also other options. So it says ladybug is my preferred choice, but there are also other options that are less probable, but you see here a ranking of other options that could also be the truth. And this is also additional information that advanced AI systems can give to the human interpreter to make them more familiar with the results and also give a better feeling about it.
Okay, but does it mean I need to have labeled data anyhow to get this on, or do I need to give at least some reason codes on a manual base to the system that I can get this kind of an interpretation, or how is it working?
Well, this particular example is based on a supervised learning technique, yes. So the options that you see here are drawn from the labels that are inherent to the data set that the model has been built on. For unsupervised learning techniques, there are also options, for example, of giving proximities of outliers to certain clusters that have been found in order to give a better insight as to how similar a certain outlier is to a certain cluster, to indicate it could be this or that, and with this and that probability, it's rather cluster A or rather cluster B.
Okay, cool. So it's possible for both. That's great. So if we talk about anti-financial crime compliance now, maybe a short introduction, what we understand about that one. It's first of all, for the regulated industries like financial service industries, bankings, insurances, and so on. It's about anti-money laundering and counterterrorism financing, where we are talking about the usage of AI, but also on the know your customer topics. How to identify your customers the right way, how to come to a good customer risk rating. And then we have anti-bribery and corruption as a third main pillar of anti-financial crime compliance. So it's all about regulation, it's all about following the law, it's all about being as much effective as possible. But not only about being as much effective as possible, it's also about being as much efficient as possible by doing so. Because if you're regulated, you have to do it. It's not like you want to do it, it's just you have to do it. And for that, you would like to do it in a most efficient and most effective way. That leads me to some of the use cases where we figured out that we have a quite good experience in terms of the cost-benefit ratio. Heiko, would you like to start and introducing us to some of the use cases?
Yes, I'm happy to do so. Then let's please switch to the next slide. Thanks. Basically, when people think about AI-supported compliance applications, I mean, I guess the holy grail for many people would be to have AML transaction monitoring, which goes beyond the standard rule-based approach. And the easiest, or in our opinion, the most beneficial way of doing this is to use a complementary approach, which would mean to have in parallel to the rule-based model, to use, for example, an unsupervised approach like an outlier detection, to analyze transactional behavior, but also analyze customer behavior, identify that, and then generate in parallel to the rule-based model alerts and feed that into any AML software. And the benefit of that is, of course, that you gain insight into previously unknown areas, and thereby increase the effectiveness of your system. And this is something which can be done as of today. Of course, it's rarely implemented, it's rarely available, but this is, let's say, this is a very very nice use case that can be that can be used in AML transaction monitoring. And of course, the benefits are clear, right? You have, besides a strict rule-based system, you have a less you have a way more flexible approach in towards detecting anomalous behavior, yeah, by using outlier detection methods, right? And thereby also try to erase blind spots in your current compliance model.
But yeah, so it's a way to, yeah, let's say, get the filter more broader and get more into it. That means you generate more alerts than you did before by using the rule-based systems. Is that right?
In this example, yes. But of course, this is wanted, right? We want to have, and of course, here again, I guess, but that's probably something that you can comment more on. Is it also depends on the regulation to be a little bit flexible. Say, okay, this is supplementary information that, of course, people have to look into, but it should always be possible to treat let's say the machine learning based, for example, alerts in a different way than the ones that come from a rule-based model, which is more tightly bound to actual regulation, right? Because otherwise, people will be always hesitant in have. I mean, no one wants to have additional alerts or, let's say, false positives. But of course,
that's my point.
Yes, but those, I mean, anomaly detection is always a very interesting topic, because it by definition shows you areas or shows you customer behavior, transaction behavior that you have not looked into before. And then you can compare that to your rules and see whether you're missing certain aspects of your customer base and how they behave and how they maybe try to do terrorist financing or money laundering.
So that would be a sort of prevention towards new, let's say, ways that money launderers might find to get the money into the system. So obviously, yeah, as it's mentioned in the headline, it's increasing the effectiveness. But I guess we also should discuss on ways to handle those, let's say, kind of more alerts. So from a regulator perspective, and Christian, I'm not sure as your past experience comes from auditing. I guess from a regulator's perspective, there is no issue with it, because it would show that you take it serious. You will get more alerts, you get more detection, more, let's say, fraudulent behavior, or let's say at least suspicious behavior detected, and so on. So from a regulator perspective, it should be fine. So there shouldn't be any issues with any interpretation of the law or application notes that come through guidelines of the regulators and so on. Is that true, or would you see from an audit perspective any issues and any aspects we need to cover here?
Well, I observed the general tendency of people not embracing more sophisticated approaches so much, because they are a bit afraid of the sometimes overwhelming load of new false positives that might arise. Or, let's say, first of all, the sheer number of hits that they get, and then having to identify which of them are actually false positives and which not. I guess there is a natural trade-off between effectiveness and efficiency, obviously. So it always also depends on the use case that you have. How important is it to be 100% effective? Sometimes it can be a single transaction. If it slips through the net, it can have a devastating impact. If you have a use case where this is of utmost importance, then the balance should rather be more on the effectiveness side, but then also take countermeasures on the efficiency side in order to somehow, prevent the number of hits from exploding too much and occupying too much of your human resources that you have for review. So I'm thinking towards prioritization measures, for example, but also machine learning techniques to identify obvious false positives, at least from not so obvious false positives, to lighten the load, for example, on the first level review team.
So would mean that definitely from a risk perspective, definitely a use case that we might want to see in sanctions management, for example, which is more actual than ever, given the Russia sanctions coming through with direct and indirect sanctions. So AI can help here, and this kind of a use case might be not directly, but would be an option for that one to lower my my risk here. But it would also, from my opinion, be helpful on the onboarding side, meaning when you have to go through your KYC processes and get a better impression about whom you will onboard here and have more information and let's say also let's call it not or unstructured data that might be used as well to get a better detection rate here for probably suspicious customers in the past or in the future. Sorry. So Heiko, you switch to the next use case, or is it an adoption to the one before?
Yes, well, because first of all, we started mentioning this efficiency topic, so I thought would be a nice transition to go to the next use case, which basically was mentioned by Christian already, which is okay. And I mean, this is also always something that we are trying to propose, to always think about increased effectiveness together with efficiency at the same time in order to keep your overall system in a good shape. And one main or one very straightforward example would be alert prioritization, which is something which where you have an existing model, could be just a simple rule-based model, but based on your historical decisions, KPIs, how long, how which alerts were finally leading to SARS, which how many whether they got escalated, how long people worked on them, and different other metrics. You use this then in this case labeled data and feed it into a machine learning model which prioritizes new alerts, right? Based on your historical decisions, you then can categorize your new incoming alerts and prioritize them. And of course, this prioritization has a lot of advantages. You can, first of all, focus on the high priority alerts, directly escalating them, triggering different workflows in your systems. And I think most modern softwares now also reflect this. They have prioritization in there. They have they can trigger different workflows based on the priority of certain events. This is something where, of course, then on the other hand, in order to increase efficiency, when you have low priority alerts, you can also deal with them in a more effective way. I mean, in some examples, you could even think of automatically closing such low priority alerts or delegating them to a different department, and thereby increasing the efficiency of your system. And this is something where you have not touched your rule-based model, right? It's exactly the same. You stick with your existing regulation or with your existing implementation of your regulatory model. And all you're doing is you use the existing information from your own system that you have to deal with the alerts in a more efficient way.
So the risk model stays the same. It's just about getting more efficiency out of the existing data and the existing alerts generated, helping to prioritize them, and then maybe add something like robotic process automation or another sort of an automation to handle those alerts based on a priority, which would then allow you to put this all under a risk-based approach together. Is that my understanding?
Yes, correct. That's one of the
But then that's the use case that most of the existing users can use anyway, because it's no change to the existing system. It's just bringing in better efficiency in the usage. So should be highly interesting for all the ones who are actually running AML sanctions or KYC systems, and trying to get their alerts under control.
Correct. I mean, this is applicable to any alert generating system. So it's applicable to AML transaction monitoring, payment screening, KYC screening. Yeah, and
no matter if you use, for example, NICE Actimize, if you use FICO, if you use any other system for that one, you can be vendor agnostic.
Yeah, and another advantage is that for this use case, you might not even need to have a model which is trained on on data from across multiple banks, right? So this is something which is very specific to your own rules, to your own even compliance officers or case managers, how they work on the system. So this is something which you can effectively train completely on-prem without any public models, without having to use any public models, and without having to externalize your own data, which is also, I think, an important aspect.
And the way we can implement it would also follow those guidelines and how to handle and make up your decisions and let's say comment on your decisions and so on. That could all be implemented in an automated way, so that the application notes or the guidelines from the regulators would be totally fulfilled. Again, a question to the former auditor, Christian. Any topics you see here in terms of handling those alerts and automated decision here in regards to auditing and?
There is some aspect that we should keep in mind, and that is that the general problem of biased data, let's say. So let me make an example. Let's assume that you have no AI system currently in place. You have manual review teams doing the work on the alerts. And let's assume that for some reason, a certain subgroup of problematic transactions doesn't get realized by the peer review team for some reason whatsoever. So if you use this data as input to an AI system, the system will also learn that the seemingly problematic subgroup actually is not problematic, because this is reflected as such in the historic data. So it is always important, as soon as a new pattern is realized, to relabel historic data and retrain the model, and instantly then this new pattern will be detected in the future as well.
But human decisions are biased as well, so as we know. Agree. You need to have some sort of a quality assurance and also model retraining implemented. And
sometimes you also need something that maybe complements on the blank spots that you may have as a human. And from there comes the idea of having supervised and unsupervised models working together in order to complement each other. The supervised model rather, let's say, automizes the day-to-day work that happens on a regular basis. And a supervised model complements this approach by detecting certain blank spots, trying to find things that seem unusual, and makes reviewers aware of them, make them rethink their decisions. And once they have come to a different conclusion for a certain transaction, this can be integrated into the supervised model. And from there on, this pattern can be found consistently.
Yeah, I think I just wanted to add on that. Sorry, it's a good point. I think because in many public discussions, what I see is that people tend to say that supervised models are superior, but I mean, as Christian just said, they need to complement each other, and they both have their disadvantages and advantages. And especially in AML transaction monitoring, it's very easy to understand, right? The supervised models, they help you to have a better view on patterns that you think should be that you think that the money launderers will perform, and but on the other hand, they are weak at detecting blind spots, and unsupervised models have, exactly because they don't have this bias from previous decisions. They are more general. They're better in the shining light into all potential, let's say, for example, money laundering patterns. And yeah, exactly. So they should both be applied without saying that supervised models should always be superior, because of course the big models and the big that people discuss about in the public, usually like image recognition, those are usually supervised models, right? But especially in compliance, we think that also unsupervised models have their place. Yeah.
So there's, as we discussed, it's a sort of vendor agnostic and system agnostic that we can implement such AI models on top or close to a transaction monitoring system or a screening system. I got the question. What is the experience we have in building such models on top of legacy systems? As mentioned, whether it's FICO, NICE, Actimize, or what kind of a solution we have, because obviously, and that's also something that you can really monitor out there. So it all works in a sort of a data lab experience, but if it comes to getting implemented into the processes, you're figuring out that there are issues that might not be foreseen, or that somehow provide some barriers to get this implemented into the operational process. What are your experience, your Christian, as you have in mind that you mentioned more than 1,000 projects of experience? So obviously you found a way on how to provide those models from a lab environment into production. What are your thoughts about that?
I would say that one of the most critical aspects is probably the data gathering in the first place. So usually, especially in compliance context, you usually need to integrate different kinds of data sources in order to get to a data set from which you can actually learn. And this is, from my experience, one of the greatest impediments, the alignment between different departments to bring the relevant data sources together in order to then learn something. Still, at least based on my experience, the usual approach is to somehow get this data collected together, do the analysis, let's say, more or less independently of the actual legacy systems, then feed the results back into the systems for them to make use of it. Those connectors somehow need to be established, and depending on your system, this is sometimes simpler and sometimes harder to do. But yeah, as I said, the most critical aspect usually is the first step of getting everything aligned so that the relevant data parts actually come together in a meaningful way.
Yeah. And another challenge then is bringing these AI models from lab into production, which is often underestimated, and this underestimation is the reason why a lot of AI projects remain in the status of pilot or proof of concept. And there is and this is what we are doing in our practice, so-called data factory, which is building pipelines and building whole systems in order to assure that the data is gathered in the correct way, also in production continuously, and that also the model deployment, because these models have to be recalculated continuously or on in a certain frequency, that these models are updated in a more or less automated way and provided to the production environment in an automated way. And this is what is called ML operations. And this is exactly what, for example, we are doing in the context of this OpenGPTX governmentally funded project, where we are building a large ML ops system to automate the calculation of the training of AI models, as well as bringing them into production. This is a very hot topic right now in the industry, because a lot of large companies are looking into this space and are seeing a huge need for establishing MLOps systems.
So using DevOps as a sample and move it over to AI and having an MLOps team to handle that one. Great. But there is one topic left if we talk about AI, because if I have discussions with customers, it's all about how can we reduce false positives. So any ideas about false positive reductions in this context, Heiko?
Yes, sure. So next slide, please. So I think the reduction of false positives is, I mean, as also Christian mentioned previously already, is always a very important thing. And of course, this is always done, and it can be done via, via manual processes, via statistical methods, but there's also very nice machine learning based optimization methods available, which can use historical decisions again, labeled data. So you have false positives, you have your, in the end, confusion matrix telling you, okay, which alerts have actually been false positives and which ones not, and then use that in order to train or not really train your model, but basically fine-tune your parameters of your, for example, person screening, your name matching algorithm. So all matching algorithms work with some parameters which can be changed in order to optimize them. And of course, then it's very easy, because you have your historical data. You can say, okay, I want to keep, ideally, I want to keep the true positive rate constant, or even improve it, while at the same time reducing your false positive rate, and then let the model run, and it will find parameters, and you have some freedom with the parameters in a way that those constraints are fulfilled. And I think this is already done in the industry and in many other sectors. And I think there have also been projects in especially name screening context in compliance where this has been done. And especially in terms of reducing false positives, this is one of the best applications, I would say. Especially in systems where you have a lot of false positives, which generally speaking is the case in compliance, because you try to be overly careful. You have a very conservative rule set, and of course this leads to mainly false positives, right? And reducing them is, of course, I mean, it increases efficiency, it saves costs in so many places. So this is, of course, a very important use case also, where I can help you.
What's the risk of let's say defining or getting a decision that a true positive is handled as a false positive? Indeed, can we somehow ensure the quality here of the model as well, as we discussed before, maybe, Christian?
Well, I guess one upside of this area is that massive amounts of labeled data is generated every day, basically by your review teams already. So with every day that passes by, the amount of historic data gets bigger and bigger, and therefore the quality of the models can also improve. But what I said earlier applies here even more. So if let's say manual reviews are somehow biased, and even if it's unintended, this will be reflected in the data that is produced, and therefore will also find to some extent way into the AI models. So you should not expect models to identify completely different things than your actual review team would, unless take some precautions, as I mentioned earlier, in combining those, for example, with unsupervised approaches as well.
But I can run and train my model in parallel without using the the decisions provided by the models and see how the quality is improving. And then when I see that the model has the right quality, then I'm just put it or bring it into production. Would that be an option as well?
It depends how you define quality. So if you measure quality against what the average human reviewer would do, I would assume that with sufficient data and proper calibration, an AI model would soon get to a similar quality as the human reviewer would. But the AI model has, let's say, two major flaws, as I would see it. First is that it will not detect different kinds of problematic transactions. For example, if the data produced by the reviewers doesn't show it. So you would need the embedding of unsupervised approaches to complement those blank spots. And yeah, against this background, it depends also how you define quality.
Yeah, sure. But see, what we definitely want to avoid is, let's say, reducing false positives on the one side, but raising on the other side the risk of missing true positives, for example. So that's given. Maybe we there are more use cases that we can think about. It's for example model governance to support or get AI support in providing model governance and ensure that your model is effective and somehow efficient, can be done by using machine learning algorithms as well. It's the same thing like I saw from the IMF a research paper where they used machine learning to figure out the effects of financial sanctions, for example, on a macro level. So it's not only that we can provide on the micro level of one company some sort of support, but also on a macro level, on a wider level. Even on a supernatural national level, we can provide some support here. But the question is, and that was raised already, what are, to each of you, everybody has at least 3 topics. What are the 3 major success factors for getting AI implemented in anti-financial crime compliance? Just maybe like we did the introduction, maybe Jörg, you can start first.
I think first of all, it's the first success factor is to have a clear goal and the conditions in mind. Then second is all about data. Yeah, really be aware of what data is available and what the quality of the data is. And then thirdly is not only the focus not only of implementing a model, but also keeping in mind and planning it from the beginning how getting this into production and the operation section is planned and implemented.
Thank you, Christian. From my perspective, I think 2 things are very important from an operational side. What I appreciate very much in very good project setups is if there is a good staff mix within the team. So you should have IT experts who are aware of the data. You should have business experts who know the underlying business processes that generate the data. And you should have the ML experts who somehow act as an intermediary between the 2 groups and are aware of the ML models and how to put data into context. So in more projects than I would like to see it, the staff mix is not as good as it should be. And from project where it is the case, I also see that you can make much faster progress and also in more significant stages. And second thing that I would like to mention is, especially if you're making the first steps into the AI area, I would recommend to start small and then increase. Have clearly defined objectives for your proof of concepts, maybe also with somewhat smaller budgets. Make first successes with it, and based on that, get the buy-in from your stakeholders for larger projects.
Mm-hmm. Thank you, Christian. Heiko?
Yeah, so I mean, a lot of things were mentioned already, but what I think is very important to remember that in the end, we always want to solve business use cases, right? And so there should be well defined from the start, and then only once we know exactly what problem we want to solve, then we can go into techniques. Are we using unsupervised learning, supervised learning? It's, I think, completely the wrong approach to say, I've seen about those nice, very multi-layer, deep neural networks. I want to use those, and then it makes no sense because you want to solve. They're not suitable for solving your actual problem. So start with the business use case, then go down to the technical implementation. I think that's always the right approach. And then, of course, when we talk about data, I think it's very important not only to have the data accessible that we need, but also to know which data is important, because a lot of data is available, but the models compute faster and converge faster if you focus on the right data. And this is, again, where you need people with some domain knowledge, business knowledge in your team while implementing the models, which is also something that Christian already mentioned. And then you can have focus on, instead of hundreds of thousands of different dimensions, you can reduce it to a few important ones, and then all your models converge much faster. Yeah,
thank you.
So key points.
My point would be a sort of different ones anyway. So for me, even if we can use AI, I'm more coming from how do I need to use it to stay compliant with my whole system. So it won't help me if I find the right algorithm to solve my specific problem, but at the end the whole system is not compliant anymore because you don't get the right quality, the right decision, transparency that an auditor would live with or can live with it, and the quality is not the right one. So the system should be used in a way that the whole system stays compliant. Second of all, it needs to provide the right quality, and I need to make sure that I have the right measures in place to handle quality bias in the data, as already mentioned by Christian. And at the end, I need to focus, as you mentioned, Heiko, on problem by problem and solve the different problems, maybe with different ML algorithms, so that I have an increasing effectiveness and an increasing efficiency over the time, but not can get it right that way. So I guess if we accept those limits, or let's say set the expectations right, there's nothing in the way to have some very beneficial AI implementations, even in anti-financial crime compliance. So thank you for this discussion. Hopefully everyone that followed the discussion stayed till the end, and of course the screens, the PowerPoint slides that we showed and discussed during the session will be available for download. Just follow the company slide msg-compliance.com. Just leave us your minimal contact information, and feel free to download the presentation. And of course, if you have further questions, just follow us, just meet the experts, get into a chat with them, also with me, of course, and yeah, just follow us for some more domain-specific or technological-driven talks through our next expert talks. Thanks to all, and have a nice day.
Thank you.
Thank you.
Thank you.
Thank you. Bye-bye.